All right, now that we've gotten to the chapter on normal distribution, let's talk about one aspect of normal problems that give a lot of people trouble, and that is how to tell the difference between a probability problem and an inverse normal problem. All right, the difference between a probability problem and an inverse problem. A probability problem is the first type, and that's when the given information is about the variable values. And then the information you're being asked for is a probability or a percent. Now, remember again, probability, percent, proportion, they all mean the same thing, and they all mean the area of the normal curve. When you ask for a probability or a percent, that makes it a probability problem. And on the graphing calculator, you use either normal CDF on the TI or NCD on the Casio. Now, the second type of problem is an inverse problem. That's when the problem gives you a probability or a percent, and then it asks for a variable value that goes with that probability or percent. For an inverse problem, you use invNorm on the TI or invN on the Casio. All right, so let's take a look at a couple examples. First example, a bus line is officially scheduled to be completed in 45 minutes, but in reality, because of traffic conditions, the times it takes buses to complete the line are normally distributed with a mean of 46 minutes and a standard deviation of 9 minutes. What is the probability that a randomly selected bus completes the line in less than 45 minutes? So let's go through this. First of all, there's all of this information that's up to this point. All of that information describes the situation or set up the situation, set up the background information, and it tells us that we are dealing with a normal distribution with that given mean and that standard deviation. So we're not into a particular question yet. We're just at the overall setup. Next, the part after that is for the specific of this question, and that is, what is the probability that a randomly selected bus completes the line in less than 45 minutes? Okay, so we're given a variable value. The random variable here is the number of minutes it takes a bus to finish the line. And we're given the variable value. And we're asked for probability. So that makes it a probability problem. And on the TI, we're going to use normal CDF. And on the Casio, we're going to use NCD. Because we're given variable value or values, in this case, just one value. Some problems you're given two values and you ask about the probability between them. And you ask for the probability, so that makes it a probability problem. All right, second example. Same beginning, a bus line is officially scheduled to be completed in 45 minutes, but in reality, because of traffic condition, the times it takes buses to complete the line are normally distributed with a mean of 46 minutes and standard deviation of 9 minutes. Management wants to change the official schedule so that 75% of buses will complete the line on time. What should the new time be? So this is kind of a hard problem because it takes a lot of critical reading comprehension to understand what they're talking about. But the overall structure is like this. Again, the beginning. Just set up the situation that we have something, a random variable, which is a number of minutes it takes to complete the line. And that random variable is normally distributed with a mean of 46 and standard deviation of 9. So it just describes the overall normal distribution. It hasn't asked us anything yet. Now next, management wants to change the official schedule so that 75% of buses will complete the line on time. So, whoops, my screen moves. 75% of buses. So we're given the percent. And we're asked for the new time. Well, time is the random variable. So we're given the percent or probability, and we're asked for time. So that makes this an inverse problem. And that means for TI, we're going to use invNorm. And for Casio, we're going to use invN. So that's how we figured this is an inverse problem. Okay, so you can look back and forth between the first example and second example and see the difference. All right, so now let's go back to these two examples and let me show you how I do it. Instead of trying to read and try to read and analyze and determine what kind of problem all at the same time, what I usually do, which makes it a little bit easier, is that as I read the problem, I sketch a normal curve and mark all the information that I'm given. And whatever they're asking me for, I put a question mark there. Now, one of the things that I do consistently is that if there's anything that involves the random variable, the value of the random variable, I put it below the horizontal axis. I put it below the x-axis. And anything that involves probability, I put it in the area of the curve above the axis, so I can tell the two of them apart very easily by their position. All right, so in this problem, again, bus line is officially scheduled, blah, 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 normally distributed with a mean of 46 and standard deviation of 9. So normal distribution, I'm going to draw a normal curve. Now, it doesn't have to look nice. I could draw an ugliest looking normal curve ever. Sometimes I actually draw like a hump, like a semicircle, and it works just fine. I underline the mean and I underline the standard deviation so I don't, so I can find them again, but I'm not going to mark them on here. Okay? I try to keep my graph with very little information, or only as much information as I need to figure out if it's a probability problem or an inverse problem. All right, so I have my setup of a normal distribution with the mean and standard deviation. So I draw my normal distribution and my bell curve. And then I read on. what is the probability that a randomly selected bus completes the line in less than 45 minutes? So that means there's a number 45 somewhere. And I'll put it on. It really doesn't matter where I put it. In this case, 45 happens to be a little bit smaller than the mean, so it should be to the left of the mean. But in reality, if you do it with 45 over here to the right of the mean, don't worry about it. You still get the right answer. So don't be too hung up on things. Just draw 45 somewhere. So here we go, 45. And this, the horizontal axis is my x-axis, which is time. Sometimes I don't even label the axis because I'm only doing this to figure out what kind of problem it is. I'm not trying to accurately graph anything. Okay, so they're talking about a randomly selected bus completes the line in less than 45 minutes. So 45 minutes is here and less than 45 minutes is over there. Okay? And the question is, what is the probability? So that means my question mark is up here. And so here's the rule. Question mark in the area, it makes it a probability problem. So this, after I draw the curve, I figure out that this is a probability problem. That means I'm going to use normal CDF on TI or NCD on Casio. Right, so let me box this up right here. This is my rule. If my question mark is in the area, then I know that I'm dealing with a probability problem. Right? Okay, now let's take a look at the second example. Same as before, there's all this information that says it's a normal distribution with such a mean and that standard deviation. So because it's a normal distribution, I'm going to draw my normal curve, my bell curve. Okay. The horizontal axis is the x-axis for time. Okay, management wants to change the official schedule so that 75% of buses, so that means there's an area somewhere that is 75%, will complete the line on time. On time means, so there's an area somewhere that's 75%. I'm going to have to decide if it's this area to the left or that area to the right. Well, if you do something on time, that means you either meet the time. Sorry, my screen is moving again. Either meet the time or you get there earlier. Earlier means less time. So that means we're over here. And so this area is 75%. So that's the given is an area. 75% is an area. We'll complete the line on time. What should the new time be? Well, that means they're asking for this. What's the new time? So when I draw this graph, it also helps me critically understand the reading. Okay, it helps with reading comprehension. I just realized what happens. I realized what happens is that right now the schedule says 45 minutes, but a lot of buses miss it because the average time, the mean time, is 46 minutes. Okay, so management says that's wrong. We can't tell our customers that the bus will take 45 minutes when on average it will take 46 minutes. Okay, so let's change the time. Let's change the listing to some other time where 75% of the time people will get there on time. Okay, so they're going to move the new listing to some new time over here, and they want us to tell them what that time should be. Okay, so that 75% of the buses will be there on time. So here's the rule. The rule is when the question mark is on the axis, the problem is an inverse problem. It's an inverse problem, and on the TI, we will use invNorm. And on the Casio, it's invN. So I have this rule, which I will box up. When the question mark is on the axis, I'm looking at an inverse problem. So these are my rules. If my question mark is in the area, I have a probability problem. If my question mark is on the axis, I have an inverse problem. All right, so let's summarize what we did. What we should be doing is we sketch a normal curve, draw a bell shape, and mark things on it. What are we marking? We mark the information that we're given. Anything that's a variable value, we keep it under the axis. Okay? Like a number line where you draw the axis and put the numbers under the line. Same thing here. You're going to draw the axis. You're going to draw the bell shape, and anything having to do with the variable value, put it under the axis. Anything having to do with the random variable we're working with. Anything that is a probability or a percent, we put it in the area of the curve above the axis. So, and sometimes we need to do a lot of thinking to see, like in the example 2, we've seen it, I have to do a lot of thinking to myself as to whether or not the question mark is on the left or is it on the right. But either way, it's going to be above the axis. And the information that I'm given, if it's a number, I put a number there. If it's something they're asking for, I put a question mark there. And the rule is if the question mark is in the area, it's a probability problem because I'm being asked for a probability. That makes it a probability problem. If the question mark is on the axis, if the question mark is on the number line, then that makes it an inverse problem. Okay, because it's opposite of all the probability problems we've been working on for the last chapter or 2. Okay, that makes it an inverse problem. And on the TI, we use invNorm, and on the Casio, we use invN. All right, so that's how I would figure out how to start a normal problem, to figure out if it's a probability problem or an inverse problem. All right, bye.